All right, we're started.
Okay, so just a quick note to the presenters here. This session or this webinar will be recorded, and giving your consent that this recording will take place. And yeah, I'm looking forward to this session and your contribution there. So it's my privilege to welcome everyone to this webinar on demystification of optical LAN. This webinar is brought to you by the European Committee of APOLAN, for which I am the chairman. And we are looking at the optical LAN business in Europe in specific. I just want to, at the beginning, draw your attention to the notice of antitrust and the legal and the legal disclaimers there to get this out of the way. So that all comprises the activities of APOLAN as an association, but that should be not too much to you. So if we can skip to the next slides. Yeah, so I'm doing the introductions. Obviously, there will be the main part of this presentation will be some topics that we will cover. I will go to that agenda in more detail. At the end of this session, we foresee a Q&A. We ask you to hold your questions or type your questions in the Q&A there, and then we will hopefully be able to address them and have a good discussion on the optical LAN business. At the end of this presentation, which will also be available, you can find more information on APOLAN and on optical LAN. So yeah, please go to the next slide. So here, this was the antitrust statement for everyone to be clarified, where I referred to, and then you will find the legal disclaimers on the next slide, please. Okay. So then we can have a look at the topics that we will address, or maybe first on the team that is presenting to you. So all members from the European committees, and I'm joined here today by Piers from Corning, Jean-Pierre from K-Labs, and myself from Nokia, and Paul from DIRT. They will have some time to introduce themselves during the presentation, so I'll leave it up to the speakers themselves to give you a bit more of their background. The agenda itself on the next slide. So we have seen that in the market there are sometimes some misperceptions or prejudices or rumors on optical LAN. In this session, we try to demystify a bit on these topics, and the topics that we are going to address are on the benefits of optical LAN, but also on some topics like the security and how bandwidth is managed in optical LAN. Also, the prejudice is if fiber is fragile is addressed. So there is a good mix of topics that come up when you're confronted with an optical LAN network. We'll go to the next slide, and I believe, Piers, here is the time for you to do your introduction.
Thank you, Stefan. Hi, good afternoon, everyone. So my name's Piers Benjamin. I work for Corning Optical Communications as the now Market Development Manager for Enterprise in EMEA. I've actually been with Corning for 7 years prior in the marketing department, and prior to that I actually worked for a distributor in the UK, so a good 17 years of fibre optic cables and so forth. And I'm here today to talk on a couple of topics. If we can go to the next slide, please. So I'm just going to open up with really the benefits of optical LAN. Why should we go in this direction? Historically in the building, we've seen copper as possibly the de facto solution. And why would we go fiber over that? Some of the points on here are fairly self-explanatory. We look at it really as a future-ready infrastructure. Again, we've seen copper traditionally used, but we know there are limitations there. One on the data rates of a maximum of 10 gig and a distance of 100 meters. If we look at a fiber infrastructure, our data is up to 40 gig in reality, and with single mode fibers, distances really aren't a problem, especially in the building environment. It is a secure solution, and we can see this, the architecture can be simplified, and we'll show through this presentation the idea of not having to go point to point, but using fibers into OLTs, into zone boxes, and being able to split that signal out. So the photos on the right are kind of the classic tray full of Cat6, Cat6a copper cables, or the ability to bring it down to very, very few cables. Now, as a manufacturer, this sounds ironic, talking about less product, but this type of solution can get us into that scenario. And by doing that, you then have a sustainability element as well, that you're using less product, less footprint from it. Again, I'll show some results on this as we go on, and you're future-proofing your network down the line. As I say, the unlimited distance in a building scenario plus those data rates. So with that, next slide, and I think I'm handing back to Stefan.
So quick introduction on my side, Stefan Heldens with Nokia for 30 years, but since 2017 focusing on optical LAN, winning there the first projects, and I'm doing here business management for Nokia, specifically for optical LAN. If you go to the next slide, here we address the question on why is optical LAN happening now? Why are a lot of folks now looking at optical LAN? Well, we see that in the public domain, with operators, the acceptance of fiber solutions gets more and more ingrained, is taken as a de facto solution and the future safe solution, which is there. So there is no more discussions about fiber as a technology. Everyone understands that from the public domain. At the same time, there are some other trends like the mobilization, Wi-Fi traffic with Wi-Fi 7 introduction goes up. You have also the private wireless traffic there as well. Also there you need an infrastructure, and fiber is ideal for that, to transport that amount of traffic. And then on the other hand, you have the digitalization, cloudification, greenification. You could put now AI also into that list of trends that require more from networks in terms of bandwidth and low latency, and the flexibility which an optical LAN brings. Then the counter question here is then, why is not everyone massively choosing optical LAN? Well, there is still a quite performing traditional LAN solution, and that we know the active Ethernet solutions that have been around for the last 30 years or so, and for some this is still good enough, while some people would like to go to a long-term investment assurance and would choose for an optical LAN. So that's a bit the two trends. We have really seen, and in the next slide that is illustrated, that since 2020 there is this shift, let's say, or really a shift in uptake in optical LAN there. Also maybe related to a lot of more homework being done and people rethinking their network needs, where a lot of data is put remote and you need to have the capacity to work with that. So there we have seen really a transition point, and now in the last 2 years we have a more and more accelerated, let's say, demand for optical LAN. You can go to the next slide then. Thank you. Handing back to Piers.
Yep. Thank you, Stefan. There are other presenters, I promise, not just us two, that we'll talk in a while. I'm going to look now really at the benefits of remote powering, particularly on ONTs, but within the network. I think, again, power is sometimes the element that can be a struggle if there's no local power available, and fiber's not considered a solution you can run power with. I would actually go as far as to say power over Ethernet is one of the things that has actually kept copper going, being able to run up to 90 watts through those type of cables. So how can we do this with fiber? and we will show that as we go through. But it's really this idea of using power at the head end and cables that can support that, and then being able to hit the devices at the edge or the ONTs at the edge of the system. Several reasons for doing it. I'd say the biggest element is really being able to centralize it within the server room. If we can just go to the next slide, though, I'll show how we can do this. The first thing what we would recommend is using these hybrid cables. These are cables generally with fiber for the data, from 2 up to 12, 24 fibers, and then copper cores in there for the power element. Now, if you like, this is an idea of power and Ethernet together. So using fiber up to 40 gigs, and then power actually up to 600 meters. So again, if we look at traditional infrastructure, we're limited on our power and data through a Cat6 or 6A cable of up to 100 meters, and up to 10 gig with 6A. Here we can go at 40 gig, but interestingly, we can actually hit 600 meters up to PoE plus, and over 400 meters at PoE++, so up to 90 watts. So this solution allows you to go further distances within the building, within the network. It also has that redundancy as devices that come off the ONTs need more wattage. It will support that HPoE type solution. If we can go to the next slide, please. Obviously, we can do that through the cable. How do we actually power it? And what we recommend is the idea of using remote power or PSUs at the server room. These will sit generally in the 19-inch frame, and then you'd run the composite cable as a rule into a panel, and then run the power and data from that panel out to the edge of the network, out to the ONTs, into the zone boxes we show here. And then from there you can hit the devices. Again, you'd still need a traditional copper element right at the edge, but as devices catch up, hopefully that will be removed and it'll be pure fiber all the way. But this again allows everything to be centralized within the server room. No need to find local power within the network, hit those hard to reach devices and remove an element of complexity that's potentially been within an optical network design historically. Can I have the next slide, please? And here, just really showing the different architectures. I think the right-hand side one is our traditional one. If you look at that, it's going to be a point-to-point type solution with an individual cable going to each device. So one, you're limited at 100 meters on a copper network. Secondly, each device needs a cable. So if we go back to that very early picture I showed, your trays suddenly look very full. You've got a lot of infrastructure, a lot of investment. Alternatively, we can run this on the left-hand side from the switch server room through a composite cable, your power and data going through one cable, then hitting the OLT and being split out to the multiple devices. So you're able to go further, you've got more data budget within that, and you've got less infrastructure needed for it. And then next slide, please. And then just finally, as I say, I touched on some of the environmental impacts, i.e. the less infrastructure side, but there's here, and I can share this white paper actually later after the event. This was a study done on Corning's own HQ in Charlotte in North Carolina. So we put this kind of intelligent networking system in pure fiber. We called it a wireless first system. And we believed in it so heavily, we got this train in to carry out this survey and write the white paper showing the savings that it did. And it showed two things. One, a financial saving, which you can see on the left-hand side. There was less infrastructure needed, but also moving forward, less costs in there, both from the CapEx and OpEx side. But importantly, in the modern environment, there was also a large environmental impact that came out of this. And just some of the highlights on here, the energy saved through it, and a big reduction on emissions, both the carbon emissions, both operational and embedded ones, and just some examples of how much was saved compared to going down a traditional side. The other saving that came out of this, which isn't listed on here, was by using this fiber infrastructure, we were able to bring the cable trays down from 12 to 8 inches. And again, having both an environmental saving on less materials, but to the customer, less investment needed in that infrastructure. So there were several things there that kicked in, and it showed a real green message going down this type of solution. As I say, this is available on the website. I can share it with the audience afterwards. And that white paper was done by a third party. And we opened ourselves up believing in that solution to them. And I think I hand over from here.
You do. Thanks, Piers. Really appreciate that. Just welcome, everybody. My name's Paul Mills. I'm the global product manager for a company called Dirt. I'm actually based out of Austin, Texas. So yes, it's very early in the morning here. And we are a smart interior construction company. And as part of our solutions, we provide optical LAN. Can I go to the next slide, please? So really what I want to focus on today is really what impact optical LAN has had on deployment and installation skills. So the key thing that we want to look at is what is the core impact, and we'll look at the fundamental shift, what the skill set changes are, and really what the new skills are required for these optical LAN installers. We'll also look at deployment practice evolution, and I know that Piers and Stefan have already covered part of this. We'll look at the physical layer, the actual network architecture, site planning and design. And at the end, we're going to look at the challenges and the opportunities. There's always challenges for installers, but really we want to focus on the opportunities for really any low voltage contractor that's moving into this new technology. Next slide, please. So what is the fundamental shift? Well, we're actually replacing as much of the horizontal copper solution for fiber. So we're actually taking that fiber cable as far as we can into the work area as possible. And really, what does that mean? Well, we have to start talking about additional acronyms now like OLT and ONT. So optical line terminal, which is really the brains of the system. And then we're talking about optical network terminals, which is the edge devices. So these are terms that really installers are going to have to get used to using. And I know there's enough acronyms in this type of technology already. So what are the skill set changes? So traditionally, a low voltage contractor is terminating copper cables, be it Cat5e, Cat6 or Cat6a. And unfortunately, that type of skill set now has been passed on in certain cases to electrical contractors as well. So really looking at this as a technology, we need to have a real good understanding of things like PoE and also the current standards, be it TIA and IEEE standards. So for an installer moving into this type of technology, we're going to be talking about things like fusion splicing, mechanical connectors, understanding things like optical power budgets and light loss, really understanding the different fiber types. And I've mentioned single mode here. Jean-Pierre is going to talk about multimode, I'm sure, because his technology uses multimode as well. And really things like how are we going to test these products or test these installations? And you'll hear things like OTDR and optical power meters. One of the things that we do at our company is we provide prefabricated links. So the fiber cables themselves, we can actually cut those to length and we can pre-terminate them and pre-test them. So this is something that somebody who's just really newly moving into this technology, they can use this. And I know there's other vendors out there that offer pre-terminated solutions. And that doesn't just apply to the fiber side of things. It also applies to the copper because, yes, we still do use copper in an optical LAN solution. Next slide, please. So how is this changing as a deployment from traditional copper installations? And you can just about see on that image there, with a traditional copper installation, we have lots of copper cabling, large bundles of copper cabling, and that needs to be supported on some form of basket tray or unistrut type system. With fiber, we can replace a lot of the copper cabling with less fiber cabling, which means in certain instances we can actually completely replace these trays, or we can even put it on J hooks. Another thing, and this was mentioned by Piers about the longer distances, And what that means is we can actually reduce the amount of IDF closets and TR closets as well. So from going from a 100-meter, or in the US here, a 328 foot distance limitation with copper, we can now extend that fiber cabling up to 12 miles or 20 kilometers. One of the key things that we need to be aware of with fiber is the health and safety aspect of it. Fiber is glass at the end of the day. So the area where we're working in has to be clean, but we also need to look at it from a health and safety aspect, because a shard of fiber, if you get it on your finger and you accidentally rub your eye, that can go into your eye. So we have to be aware of all of the health and safety aspects relating to this. If we look at the network architecture, really, optical LANs differ in the fact that a lot of the management is from a single pane of glass. A lot of the vendors out there who provide this type of technology utilize an orchestration platform to configure the network, which is an advantage because you can now manage the whole network from a single location rather than multiple comms rooms. And obviously, there's a training requirement for the installers there. Obviously, with an OLT, we've now got just a single point of failure. We're not looking at multiple switch locations where we could potentially have that failure. And the other key thing we need to take into consideration is the endpoints, which are the ONTs. A lot of the time, they're not actually mounted in the IDF closets. They're actually mounted in the work area. So there has to be consideration there as to where those ONTs can be mounted. And that could be up in the plenum. It could be under a raised access floor, and in our case, we actually mount it into our wall cavity itself. But the key message I want to get over here is, and this applies to any network design, the network design should be happening at the beginning of the design stage, when the floor plate is actually being designed. There's many a time when I actually receive drawings and people ask me to put together an optical LAN design for them, and I'll look on the floor and there's 6 different IDF closets. We can actually free up that real estate and convert those IDF closets into offices, into mother's rooms, into storerooms. So if we'd have had that conversation earlier, we'd have been able to help the architect design the space more efficiently. Next slide, please. So this is a similar image to what Piers shown, and I just want to really show how we can extend these distances. And the key things to remember here is that with a copper installation, the reason you're having multiple copper cables is one copper cable is connecting to one device. Whereas with fiber, we can actually connect a single fiber cable, in theory, to multiple devices, up to 128 devices. The distances are much longer now. So we're going from that 100 meters up to 20 kilometers. And with PoE, because a lot of people now are using PoE, we can use this composite fiber where we can actually run a PoE circuit as well as the data circuit as well. Showing 600 meters here. For anybody who's online who's American, that's just over 2,000 feet. Next slide, please. So really, what are the challenges and the opportunities? Well, training is the big thing. You know, you're now looking at a completely different topology. So there is going to be challenges for the installer in the fact that they've got to learn not just the installation of the passive fiber, but also potentially the active side. And we do work with low voltage contractors who just do the passive side, but it's important that that head end is also managed as well. There is going to be an initial investment, things like OTDRs and fusion splicers. If you can't afford the fusion splicer, there are mechanical connections that you can do in the field as well. There is really a lack of widespread experience in a full optical LAN solution. As I say, certain vendors or certain installers only do the passive side, and there is still a limited awareness in the marketplace for optical LAN. The technology has been around for about 25 years, but I still speak to some low voltage contractors and they're still new to this. So trying to get that message out, which is what APOLAN are trying to do. And there are some verticals that are difficult to break into. Healthcare has been one of them for us in the US. But we're slowly breaking into there by focusing just on things like cellular or Wi-Fi connectivity. And let's be honest, not all projects are suitable for optical LAN. We have to take that into consideration. But what are the key opportunities for the installer? You'll hear this word, smart buildings. Smart buildings are a big thing, and this is really a future-ready solution for smart buildings. The birth of AI now is actually driving this even further. Higher education campuses, multi-dwelling units, really that support for the Wi-Fi and cellular networks with Wi-Fi 7 now and 5G infrastructures. We can support that over the fiber infrastructure. One of the big sellers here is hospitality and stadiums because of the extended distances and the types of services that are being run in those particular verticals. The other key thing that I just want to touch on very quickly before I move it back to Stefan is this is a great green type of solution. From a sustainability message with things like embodied carbon and operational carbon, really Optical LAN is a great message for those particular types of conversations. It uses a lot less energy and it's a lot easier to manufacture Optical LAN and fiber cabling than it is with copper cabling. I'm now going to pass it back over to Stefan. Thank you very much.
Thanks, Paul. Very clear. With new technologies, normally new investments are coming there. Now, in the case of Optical LAN, there is actually a cost saving that can be achieved. So you get a more performant, more bandwidth, lower latency solution with an Optical LAN. So in terms of bringing that to concrete figures, we've done simulations, and these are averages, but they are representable for different regions as well. But it gives also a clear indication on what type of savings can be done. So if we take a look at the total cost of ownership over 5 years, for instance, for projects, here different size of projects. And by the way, I think the smallest type of project start around 150 Ethernet ports, but that depends a bit on the vendor and also the topology of the project. So the larger a surface is, so a large area will have a better business case than when everything is very dense. Why is that? Because with our fiber, we can span easily 20 kilometers, where a copper cable is restricted to 90 meters. So here showing the type of savings around 40 to 50%, depending on the size and where they can be achieved. You will see a large part of that is on the passive on the passive side, also on the cabling, and that is also kind of coming back to an earlier question, why some cable vendors that are focusing on copper cabling would rather that folks remain with a traditional LAN solution, where there are these large cable bundles that were shown also on the pictures shown by Paul and Piers. Good, can go to the next one. Yeah, we sometimes at the beginning of the presentation I talked about some prejudice on some rumors that are spread on Optical LAN, and a thing that we often hear is, yeah, but it must not be as secure as a traditional LAN solution. Well, I would like to here inform you and set the record straight that an Optical LAN solution is still an Ethernet solution. So at the user side, you still have Ethernet ports. So all the security mechanisms that are viable for an Ethernet, traditional Ethernet network apply here, and it's up to the vendors and the active vendors to see what their capabilities are there. Also, the Optical LAN kind of grew out of a public deployment, so FTTH. So there are also very high let's say requirements in terms of security and implementation. Additionally, a fiber or an Optical LAN solution brings some advantages in that sense that the signal on a fiber cannot be jammed. It doesn't have a field, and so you see in some, and then we're talking defense type of segments. These aspects of an Optical LAN solution is very much appreciated. So you cannot mess with that. It's more hard to intercept also that technology there as well. And the signal itself is also encrypted downstream for GPON, for XGS and 25 gig symmetrical. In both way, there is encryption included on the lower layer of this technology. Yeah, can go to the next one. Handing it to Jean-Pierre.
Yeah, thank you, Stephen. Hello, everyone. So I'm Jean-Pierre Gauthier. I'm a global account and an international sales manager at Collabs since 5 years right now. And the core of our company is to develop innovative components around the optic and optronic components. This is why I'm going to talk to you about fiber optical and how we can transform, for example, multi-mode fiber capacity to single-mode fiber. But this is not the first questions. Next slide, please. Let me start with the questions I hear all the time. Isn't fiber fragile? We're going to look at how fiber compares to copper in terms of mechanical strength, durability, and performances, and why fiber is actually the more robust and future-ready solutions. Today's question is simple. Is fiber really fragile? So the common belief and the misconception is that fiber optical cables have a limited lifespan, only 10 to 25 years, because they are just glasses. But it's not true. Fiber optic are not a bare glass. They are a part of fully engineering system that includes cladding, protective buffer tubes, and robust auto jackets. Specifically, here you can see that if I have input a link where you can see the specified design of optical fiber dedicated for nuclear power plants. So the table data here show you that aging test and with the Arrhenius method, this method uses an accelerating thermal aging, which allows us to simulate decades of aging in just a few weeks at higher temperature. The result is at 110 degrees Celsius for 80 days. Some cable demonstrated that service's lifetime is over 150 years. Next slide, please. Thank you. So are you still skeptical? I'm going to try to talk about mechanical strength and durability. First, let's talk about mechanical strength. Optical fiber, especially silica-based, has a lab test tensile strength of up to 1 gigapascal. In real-world application, we typically work with 200 to 500 megapascal. For comparison with the copper has tensile strength of around 200 to 250 megapascals. So yes, fiber can actually outperform coppers in terms of raw strength. Fiber is also lighter, more flexible, and resilient. And one of the very important property, its fiber is completely immune to electromagnetic interferences. So in conclusions, I think you are not still skeptical to apply definitely the optical fiber for your next choice, and especially for the optical LAN. Stéphane? Piers, sorry. It's your turn.
No, actually,
it's Stéphane.
You were right there. Yeah. It's mine. So there is this a question we often get, or a misperception that is there in the market, is to get clarity on the difference between split ratio and bandwidth. And there the presentation left me here. Yeah. Okay. Thank you, Melissa. So I want to clarify a bit and kind of show you how that is handled in an optical LAN. So you have, first of all, you have PON technologies, which actually define the available bandwidth. So you have GPON, and it goes to 2.5 downstream, 1.2 upstream. XGS PON, which goes to 10 gig symmetrical up and down, and 25 gig also symmetrical up and down. And I think in the coming years you will see 50 gig and 100 gig appearing there as well. So that is the bandwidth that is available on the fiber itself. That fiber because Optical LAN is a point-to-multipoint technology, can be split over different fibers. So typically the split ratio which we implement is a 1:32 split ratio. If we that's because there is an optical budget available. If you stick to those measurements, to those rules, then you can cover a distance of 20 kilometers there as well. So the optical signal is then split over those different fibers, but the bandwidth that is determined by the technology is available at each of those endpoints from those fibers, not at the same time, but that can be managed by quality of service settings and configurations of your OLTs and capabilities of your ONTs. So that's the optical switch sometimes, also the optical modem is used in these names. So that's all synonyms for OLTs and ONTs. And that split can be done in one stage. So either you can go from 1 fiber to 32, or you can do it in a cascade where you go first from 1 fiber to 4 fibers, and then each of those 4 fibers, split them again to 4, then you have a split ratio of 1 to 16. So it's a bit giving an overview what is the difference between split ratio and how this clarifies it. And going to the next point.
Which is me, I think, Stefan. Okay, so I'm going to finish with really why switch to fiber. I'm asking someone that works for a cabling manufacturer. I could give lots of answers, but keep it generic. I mean, ultimately, we see fiber versus copper in these environments. Copper has been there in that horizontal space forever, but things are changing. I would say ultimately this is a bandwidth issue and a distance issue. And really, future-proofing your network would be my summary ones. But if we look through this slide, we can look at areas of scalable bandwidth. We know fiber will operate at up to 40 gig. We'll go up to 20 kilometers if needed. Obviously, within a sort of enterprise environment, that distance isn't going to be the biggest issue, but well beyond the traditional 100 meters. If the design is correct, there's a space saving, a material saving, a power efficiency there, i.e. running one fiber cable, which can then be split out to several devices. All of this brings down the cost of ownership at the end of the day. So for the customer, there is a saving. They're removing that danger of rip and replace as well, as we traditionally seen with copper. As more bandwidth's been needed, the Cat6 has had to come out, the Cat6A has gone in. Eventually that's going to need to come out and be replaced by fiber. You can skip some of those technology refreshes by going straight to fiber at this point. Security is there. The gentlemen have touched on this through it. Fiber is secure. It's immune to certain electromagnetic influences and to tapping. And sustainability. Fiber is a greener solution. You're not mining tons of metal out of the ground, having to put high amounts of copper in a cable, and you need less material at the end of the day. It will support green building certifications. Again, I will reference the white paper Corning put together as a company. Happy to share that, put our sort of head on the block and for you all to see it, but it shows significant environmental savings there. And then just finally from me on this topic, also, I mean, cost savings. That is, we can talk green and everything, and absolutely that is a burning issue currently, but there is just a financial saving here. This is from several different customer case studies that have taken place. If I focus on a couple, on the office spaces, if we look at the large office, the actual saving there, was of up to 29% compared with traditional copper horizontal type solution. And within this, several edge devices, be it Wi-Fi cameras, small cells and displays. And within campuses, we see, again, even bigger savings. So where we're running potentially to multiple devices inside and outside, and potentially multiple buildings, you see a 48% cost saving for the customer. This solution will save you money down the line, one, on day one, and as I say, secondly, on avoiding the need for technology refreshes down the line. So with that, that is my part done, and I believe we move to the questions. We have said please use the question and answer feature on this. If anyone has any, please don't hold back. We're here ready to answer those, and thank you for your time. And Stefan, I will hand back to you, I think.
Yeah, thanks. And I'm listening to Melissa if there are any questions already coming in. And if so, please feel free to share.
All right. Let's see. So, can optical LAN be used as a complement to traditional LAN?
Take that question. So indeed, so I think that's a question we often can. What we do here is in this webinar, we draw kind of a black and white comparison between optical LAN and traditional LAN. That's for people to understand the technology and the topics related to optical LAN. But in the real world, you often are confronted with legacy installed systems, and there obviously we have methods to include those where, for instance, you put an SFP ONT, it's kind of an ONT on a stick, which you put into a traditional LAN SFP cage, and you can connect your traditional LAN network to your optical LAN network, and as such keep that horizontal cabling that you might have already have deployed, and where you're satisfied, and you can keep on using that part of your network. But it allows you to integrate what you have been deployed and together with the extension of that case. I see another question coming up. I'll just read it out. I think that was where can people find the reference cases on optical LAN? From our side, I think we have a number of public references documented on YouTube movies. So if you look there for optical LAN, you can find some back. Obviously, also on the website of the vendors, as well passive as active, as installers, as distributors, as partners. So these things are available. It needs to be understood that a lot of these references of ours are not public, especially when they're in sensitive areas like military or governmental deployments. That is understood that there normally you will not find so many cases there. I saw another question coming in. Yeah, can several GPON technologies coexist, like XGS-PON and newer 25 gig PON? The answer is very short there, yes. Okay, it depends obviously from the vendors. Now, just putting up my just talking in general cases, but I know that a lot of active vendors have what I call multi-PON boards. So that these are LT, so line termination boards, that can allow these technologies on the same PON. So there, then you either use coexisting elements and with the correlated optics there. This should not maybe make that note. But I know that certain vendors, of which ourselves with Nokia, we have the capability to support that for GPON, XGS-PON, and 25 gig on the same PON. Yeah. Any other questions coming in, Melissa? Let me see. Can dedicated bandwidth be guaranteed for certain ONTs or ports on ONTs, as we are talking about shared bandwidth now? No, you actually, yes, you can do quality of service settings and attribute certain qualities of service to certain points, to certain VLANs, and manage that in that regard. So you can say, for instance, if you're a vacation park, for instance, and you're deploying an IPTV service and a Wi-Fi service, then you can allocate a certain amount of bandwidth for a certain service, and even up to the end port. For instance, if you would have services used by emergency services, like the police and so on. So there you could foresee also additional configuration to make that possible. Obviously, there is always a question if the vendor supports that, but I know that there are vendors supporting that. Any other questions, Melissa, from your side that you could share? Okay, I see a message from Melissa asking on what segments are successful for Optical LAN, or which segments have been responding well to Optical LAN. I will quickly give my perception, and then also open up for the other speakers to contribute, because you should not exclusively get my perception on that. Is that, and I talked about it, the larger the surface becomes, the better the business case comes. So that's the purely financial part of it. And then there are certain segments that are kind of very sensitive to the advantages Optical LAN brings. For instance, governments will go for that security aspects there. And we saw also, you might have seen that drones are being let's say controlled by having a fiber. That is just because these fibers cannot be intercepted and cannot be jammed and cannot be messed with. So that's why there for certain segments these are better. Also in hospitals, for instance, where you have large machines like scanners and so on, if you run a fiber by that equipment, it will not be impacted by those things. Also industrial environments. I don't know, Piers or anyone else, Paul or Jean-Pierre, if you have anything to add to that explanation.
I think Piers, from a US perspective, hospitality is a big vertical for us over here. Obviously, hotels now are providing a lot of services, Wi-Fi, point of sale, TV services that they're actually running across the fiber network. So that's a big thing for us. From a commercial space, if we're working with clients who have office blocks that have got multiple floors, we work very well with them, because obviously we can now pull a lot of the cabling back to a single location rather than having a lot of IDF closets across multiple floors. And the key driver for us is facilities managers, because the space in the plenum is becoming more and more limited. And when you're trying to put, 24-inch basket trays everywhere to run your copper cabling, the same, we just haven't got the space. So facilities managers are really opening up towards fiber optic topologies now, because we can run a lot of the cabling on J-hooks instead of actual basket tray. We actually did a project in Vancouver, and the architect pushed for an optical LAN solution, because in their eyes, they wanted their space to be beautiful, and they didn't want to see raceways of blue or white cabling as it is here in the US, or it would be obviously purple cabling over in Europe. So they opted for an optical LAN solution. Piers?
Yeah, thanks, Paul. I mean, hospitality, totally agree with. I mean, we see it both in the US and more in Europe and the Middle East. and whether it's just, as you say, that connectivity or running fibers directly into the rooms is a definite area. Stadiums is the other one, particularly in this region. I see an uplift coming in. We look at some of the events coming up and some of the new builds happening and that sort of large environment and having to go beyond 100 meters. And just really an example of where I kind of see it being deployed. A stadium I go to far often in the UK on the south coast of England has a smart retail facility, concessions for beer, wine, halftime pies or whatever, and they've now implemented a system where you tap your card, several cameras take images of you, follow you around the shop, you pick up what you want and you walk out again, it charges your account. So you've probably got 4 or 5 cameras hitting that person each time, and you've got what, 5,000 people in the stand, so let's say 300-400 using it in that 15-minute period. The amount of bandwidth needed and then the power needed is just perfect for this type of solution, and the length of the facilities beyond 100 meters. So whilst we're seeing stadium builds which will definitely or logically adopt fiber, you'll see retrofitting as well as newer technologies come in and people needing, be it these sort of halftime shops or the Wi-Fi 7 devices going in. So it's worth looking at it in 2 ways on stadiums. One, the new builds coming with the events, but also the technology coming in the existing ones, which just Cat6a isn't going to cope with.
Thanks, Piers. Then I see here in the chat another question. Is PON a good technology to use on the energy market as Goose protocol apply? So there, again, I think if the Goose protocol, I think it is, but we're not confronted directly with that, is time sensitive and susceptible to latency. I think you cannot have a faster solution as an optical LAN solution. Of course, there we need to see on which subsystems that there are, depending on which protocol that is there. So that is for me most likely yes, but it also what we do is kind of do these blueprint validation per segments and then see if these protocols can be supported. So I would suspect it can. We have certainly in our reference base power plants, utilities, and so that use optical LAN to connect substation and so on. So therefore, I think it can be a viable technology. But again, there the devil is in the detail, and there it's also, I believe, vendor dependent. Which protocols they want to commit to, and that needs to have further investigation. So I think yes, but it's vendor specific, I think. Good. I think if there are no more questions here, I invite you to reach out to us if there should be more questions. If you are interested in the technology, you want to talk about this more, either via APOLAN or via the vendors that are member in APOLAN. There you can always find more information on the technology, on white papers, as Piers and other speakers refer to on certain topics. And we welcome your questions and welcome you hopefully on one of our webinars in the future as well. Thank you everyone for connecting, and thank you.